Today there are still three problems that exist with 3D printing. The parts are not functional, they're too expensive, and you can't make them in enough size or enough volume. And these are the three issues that we're currently addressing with BASF. The desire to make an industrial part that's fit to use and is at a cost that's acceptable. The size is addressed by making things with screens. It's the only truly scalable mechanism of encoding digital light in volume across an entire XY platform that could be as big as a 98-inch TV screen or as small as a number of high-resolution virtual reality headset screens in a large array. For the first time, this answers the scale argument. You can create as many objects as you want at the resolution that you want in the entire XY plane. And then with clever techniques, we've managed to increase the speed in the Z-axis to give you truly transformative volumes. The second point, which is the problem of cost, is being addressed mutually by BASF and Photocentric, who have a commitment to offer industrial end users prices that are more comparable to those of injection molding than the very high prototyping costs.
And linking that with the tools, with the expertise in 3D printing and the hardware and also the chemistry of BASF, we have the best solution together to really engage rapidly additive manufacturing. And what Photocentric has been able to do today is to come with a real innovation with the LCD screens to make machines, hardware that can really make system reliable, effective, productive at a very affordable cost, and linking that with BASF chemistry behind to enable the right properties and satisfying new applications. And so for us today, partnering with Photocentric enable new solutions and give us the opportunity together to go further onto the additive manufacturing and the applications.
BASF. We create chemistry.